So a really important thing to understand, and after having seen a few of the first people take the 3B test, is that you need to know the difference between mass and weight. They're related, they're very close, but they're not the same thing. Mass has got units of kilograms. Whoops, we can go tens of kilograms, kind of works. And weight is in newtons. So you've got kilograms and newtons for your two different units for those sorts of things. And so just if you see the units being different on a number, if they say you have a 600 Newton crate versus a 200 kilogram wagon, those different objects and their units really matter in terms of making that distinction. So just being able to identify that mass is in kilograms and weight is in newtons is important. Also, mass could be in grams, but for physics, we want to always convert to kilograms using the King Henry die by drinking chocolate milk sort of methods. The symbol for mass in an equation is also a nice simple m. And for weight, in the way that I always write it, it's always F, that's bizarre, F sub G. It's really off scale. Yeah, I know. It's not calibrated right. So F, F.
Yeah, that's.
I gotta like ignore what's on screen and just write it. Okay. So the calibration thing. It's F sub G with a subscript is how weight is. In some textbooks, and I think in the freshman textbook, it was a W was the answer for that. And I can understand why you'd want to do that, but that's not how we do it in this physics class. The equation is really the key to figuring it out. And so you want to think about Fg equals m times g. The fact that both the force and the mass show up in this equation is sort of a hint that they're separate things and that you shouldn't think about them as the same interchangeable idea. So there's that. And then the next question, C, which is appropriate to place in a free body diagram, the weight of the mass. Free body diagrams, which are these things here, free body diagrams are the ideas you have when you're playing with all the forces that are acting on a thing. So like here's a force that goes up, and then you have a force that goes down, and this might be a weight, and so you handle it by putting in those. You might have a normal force, and this is a force of gravity. Mass never makes it into a free body diagram. It's always the weight that goes in. And so some problems will set you up so that you're ready to go with the free body diagram by giving you a weight. Others will give you a mass that you need to convert. So that's something to keep an eye on. All right, this is our very first video. So I'm going to